we've talked about problem number 5. Okay, for the record, is anyone going to have a freak out session that the worksheet starts with problem number 5? Are you going to be okay with that? You could fake a freak out session. I would prefer you not to today, if that's okay. Maybe tomorrow. Okay, thank you though for volunteering. Okay, we've done problems like this before. Yes. How did we do this problem? We put it in logarithmic form, right? Okay, so we said log base 6 of 104 equals x. How easy is that? Pretty easy, because in your calculator you just say log base 6 of 104 and hit enter. 2.5921. 2.5921. If we're rounding to 4, right? Rounding to the 10,000th place. I want to show you a different way today. And I have a really good reason for it. For the record, I always have really good reasons for showing you more than one way. Okay? Today, I think you'll really, really understand the reason. Sometimes it's just so you have another way. Sometimes it's because there's a really good reason. Okay? Here's the second way that I want you to know how to do this problem. If I do the same thing to both sides of the equation, is that allowed? Like if I multiply both sides of the equation by 2, if I add both sides of the equation with 7 or something like that. If I square both sides of the equation, is that allowed? It is, right? So what if I took the log of both sides of the equation? Is that allowed? As long as I do it to both, right? Okay, so let's take the log of both sides then. So I have log of 6 to the x equals log of, perfect. What happens to the x? It moves to the front as a multiplier, right? Multiplier, okay. So x log of 6 equals log of 104. How would I solve for x? Divide both sides by log of 6, right? So log of 104 over log of 6. Okay, so far? Log of 104. Nope. Go back. Log of 104. Why don't I have to put a base this time? It's already base 10, right? I purposely took just log, which means log base 10, correct? Divided by log of 6. Oh, look, it's the same. 2.5921. So why in the world, if I teach you this first, which is literally 2 steps, would I then go back and teach you this one, which is more than 2 steps? It's longer. In case it's different, so you know more ways, okay? Every single one of you have one of these calculators and carry it with you 100% of the time. Oh, no? Every single one of you have this and carry it with you 100% of the time. Facts. At all of you. Right? Okay? You cannot do this on this. But you can do this on this. Okay? You cannot. At least not that I know of. Okay? We all know that we have this calculator, and if we turn it to the side, there's this other calculator, right? Look right here. Log base 10 and natural log. They're both here. But log base 2 is not here. Log base 12 is not here. Log base 6 is not here. Okay? But if I said to my calculator, well, not said, but pushed, right? I don't usually talk to my calculator. I mean, sometimes I do, but that's just in long days. 104 log. Now I had to put it in a little backwards, right? I had to say 104 log divided by 6 log. Enter. Huh. Look at that. So I forgot my calculator at school. Doesn't work anymore. Okay? This is why I want you to know both of these ways. Yes, this is easier. I get that. Okay? But knowing two different ways for things, it makes you a lot more flexible about things that can happen. This one for sure if you forget your calculator. Because we know how to do it in the phones now I showed you. Okay? Any questions about that? All right, let's do one more just to make sure that we are okay with it. Let's do number 6. First of all, I could say log base 1.5 of 22 equals x. And I could put that in my calculator. Log base 1.5 of 22 and get x equals 7.62345. I know that's 5 decimal places, but they're all nice and 2, 3, 4, 5. Okay? Yep. 6, 7. 7. Or I could take the log of both sides and have the log of this side, which is 1.5 to the x power, equals log of 22. If I bring x down in front as a multiplier, which is what I should do, because of, well, what I can do because of properties of logarithms. When I divide both sides to isolate the x, I would divide both sides by log of 1.5. Oops, can I fix it? Log of 22, that's what I'm dividing by. I was saying it but writing it wrong. Sorry about that. So if I do 22 log divided by 1.5 log, 7.62345. Oh, you can't see that. There. Cool? Please circle 7 and 8. Change of base property. Change of base property is not something we really have to know anymore because of these calculators, but we need to know it just in case. Okay? So change of base property, if you have log base b of n, it's log of n divided by log of b. How are you going to remember that? How are you going to remember which one goes where? These are going to be numbers. How about the base is the bottom? Right? Base is the bottom. Now the way it's set up right here, this is nice because the n also could mean numerator, right? But again, those are going to be numbers, so there's not going to be a b and an n. Maybe, but they'll be constants or variables for sure. Okay? So if I'm doing log base 8 of 32, that becomes log of 32 over log of 8. So 32 log, oh, you can't see that, divided by 8 log. What are you going to write as your answer for this problem? You guys just made me happy. How about 1 2/3, right? Now, could you write 1.6 with a repeating bar over it? Yeah. This one's more accurate, isn't it? 2/3. Okay. Now, we could check that, couldn't we? Like if we really wanted to make sure that we were doing this exactly right, we could say log base 8 of 32. Because these calculators will do different bases, right? But if we're at a point where we can't do that, we have a way to do it. Okay, change your base property. What about number 10? Can you do this one without the calculator? Write what it's supposed to be. Do that for me. Log of 1 over 49 over log of 7. Can you do this in your head? If we thought about it in exponential form, it would be 7 to some power equals 1 over 49. Well, 7 to the second power is 49. How do we get it in the denominator? -2, right? Do I need to do that in the calculator for you to like prove that it's right? Or are you good? You good? Okay. What about 13? Okay, so here's my question then. It says, with a calculator, evaluate each expression. Yeah, I can't, can I? No, because it has a variable. Now, I could store a value for x or k in my calculator and put it in, but that wouldn't be really what this represents. There's a variable here, so I can't do anything further than this. What about 14? Same thing? Yeah, but we want to go ahead and write the change of base formula, right? So log of, excellent. Any questions? Okay. Next page. Next page we've done a little bit. We're going to change the directions on this just slightly because they want you to use the change of base formula for this. I would rather you think of these in transformation rules. So we're going to sketch the graph of each function. Okay? Tell me transformationally how this compares to its parent. Left 4, right? So it shifted left 4. Now it normally looks something like this, right? Right? That's the parent function. So if I go left 4, 1, 2, 3, 4, it should be, whoops, I don't want a dotted line for this one. It should be something like that, right? Yeah, that's what I want. You can please circle 18 and 19 for me. Number 20 is like one that I gave you on a worksheet before when I said, I'm not going to show you how to do this. I want you to try it. And most of you did and got one of 2 or 3 different answers. Okay? But I did tell you I will show you how to do this later. I just want you to try it first. You remember that? Well, today is later. Okay? So I'm going to give you some formal instruction on making sure you know how to do these. All right? This is an inequality. Now it's asking me to graph. The problem is there any y's in this inequality? No. Okay? But we're still going to use a graph to solve it. What we're going to do is we're going to put this part of the inequality into y1, or in our calculators as f1, right? So log base 3 of x plus 5. And then in the second function, y2 or f2, we're going to put the other side. Okay? Now transformationally, you know this shifts to the left 5, right? So if this was the parent function right here, I know it's going to move left 5, 1, 2, 3, 4, 5. So it's going to look something like that, correct? What does this look like graphed? It's the horizontal line that crosses the y-axis at 2. So like that, right? Now, you can do this in your calculator. I'm just trying to have you think about it a little bit, but you can absolutely do this in your calculator, okay? My question is this, and the question that's being asked is this. When is the log part, this line right here, when is it less than 2? When is this line less than this part right here? That's what we have to figure out. Okay? Now, for the record, I just sketched this without looking at the graph. I'm telling you right now the sketch is a bad one. Okay? Not bad. It's just, it doesn't look like what the answer is going to be. Can you forgive me for that, please? So just so we have the right idea, I'm going to sketch it in the calculator for us to have and use. Okay? We're going to go to a graph. In F1, we're going to say log base 3 of x plus 5. And I'm going to hit tab again, and in an F2, I'm going to put 2. Ugh, why isn't it letting you see this? I don't understand why it stopped doing this. super frustrating. Can you see both of them kind of? So do you see where they're crossing? That's really the important part here, is where they cross. So I could have done a way better job. Make it more like that. So ignore that top part.